Hi, I'm Carl, and in this video we're going to cover questions 16 to 19 of section 3 of the green booklet. 16 and 17 are one question and they look at aspects of lung function by using the bell jar experiment. This is probably something you've seen before, and I won't copy the diagram because theirs is very good, so make sure you're looking at that throughout. But question 16 says, of the following, a lung is best represented by what? Well, we can see as the diaphragm moves down, the balloon inflates just like the lungs do when the diaphragm moves down in humans. Therefore, the lung is best represented by the balloon. And so the question 16, the right answer is B, the balloon. 17 says, in the sequence of events that leads to the inflation of the balloon in figure 1, which one of the following occurs earliest? So as the diaphragm moves down, we have to remember a closed system around the balloon. There's no gaps because of this rubber stopper, which means the air pressure, or the amount of air, is constant around the balloon. So the amount of air is constant, but the volume of the available space available for that air is increasing. And so the pressure of that air is decreasing. Of course, remember that pressure is going to be the amount of gas over the volume. So if you increase the volume, you're going to decrease the pressure. And if you decrease the pressure around the balloon so that the pressure inside the balloon is greater than that outside of the balloon will start to inflate. And so the thoracic air pressure, this closed system around the balloon, is going to decrease as you pull down the diaphragm. And that's what causes air to rush into the balloon. And so the answer for number 17, because of this equation, is going to be D. Moving on to 18 and 19 now, we're looking at a different figure, and I've copied out the graph on the right hand side here. It talks about how blood is filtered by the kidneys and the role that nephrons play in this. They're described as long, thin tubes, and the graph really shows how the concentration of urine might change as the plasma glucose concentration changes relative to the filtrate. So if we look at question 18, it says for glucose at a plasma concentration of 1, the glucose concentration in filtrate is higher than in urine. Why? Well, we can see there's a part of the graph here where the urine just doesn't get any glucose, which means that, of course, the filtrate does, and that means that any urine that's present within the nephron is going to be actively transported out in this first section of the nephron. And this active transport of glucose is really important to stop us losing too much glucose in our urine, and instead it's brought into the filtrate so that it can be recycled into the bloodstream. So that means the answer for 18 is going to be A, because glucose is actively transported back into the blood to stop us losing too much. So the answer is A. If we look at 19, then it says figure 1 indicates that all glucose absorbed from the filtrate above or below which level. And we can see that the level is quite clear here. I didn't copy out the scale because theirs is a lot clearer than I could draw it. You can see that it's going to be around 2.2 milligrams per milliliter. And we can see that it's all absorbed below that concentration. And it's going to be the filtrate concentration, of course, because it's going to be absorbed into the filtrate from the urine. Or as the filtrate moves down the nephron, it will become urine at the very end. So by the end of the time it's gone through this big long tube, it's going to be reabsorbed, and that will happen below a filtrate concentration of about 2.2. So that means the answer for 19 is A. Just to go on with this a little bit, as the plasma glucose concentration increases, then there's too much glucose in the filtrate to be all absorbed back in. There's only so much that can be absorbed back in, and that's why at this level here we start to see a rising glucose concentration in the urine, because that's the excess that couldn't be reabsorbed. So that's why the shape of the graph looks like this. That was questions 16 and 17, 18 and 19 in section 3 of the green booklet. I hope